are you?
Hi. Good. How are
Yeah,
you?
yeah, I'm good. I'm also good. Okay, let's start our discussion.
Yeah.
Last class we studied freeze equation, right?
Mhm.
Are you recalling that what was the freeze equation that we derived?
Yeah.
Can you tell me what was the PR?
So PT GT GR over 4 pi
PT GT 4 pi, yeah, GR 4 pi D.
D squared. Oh yeah. Oh
Yeah,
yeah.
is it was like that something, right?
Yeah.
Okay. Okay, let's discuss some of the numerical from your question paper. Okay,
Yeah.
I'm just searching what all questions can be taken care from here. Okay, maintenance. Let's see whether we have some. Oh, I am seeing one paper in 2015-16 semester one examination. I am seeing one question number 1D. Are you able to see that paper?
Just a second.
Question number 1D.
Okay. I'll
Are
read
you
you a
able to
check.
see the paper?
Yeah.
And one my question to you, do they have changed your syllabus? Because I am seeing from 2015 to 2023 paper, there are a lot of dissimilarities in questions. Have they changed something?
So the last ones like from 2021 to like I think they are different because it's a new professor.
They're a new professor, right?
Yeah.
Okay, because question pattern are quite different and they are quite unique questions in 2021 and 22 and yeah, these two paper. And what about this year?
So the for the one that was last year, so 2022, 2023 exam is
Yeah,
different. You can see I sent all of them.
2022 and 23, right?
Yeah, so 2022 and 2023 are different.
Okay, so for you, which type of paper will come? 2023 paper or older paper?
2023.
Okay, the paper will come like 2023, right? Okay, okay, okay. See question number 1 and D. Can we apply freeze equation there?
Christian. Yeah. So
Can we apply?
I think so.
Yeah. How can we apply?
Well, let's see. Transmit antenna
See,
gain.
whatever the given in the question, can you tell me
So we
what
have
parameter is given in question?
so we have transmit antenna gain. We have
Gain
frequency.
is given, right?
Yeah.
Right. Okay. And receive antenna is also given,
Yeah.
right?
Yeah.
Receiver sensitivity is nothing but power received. Okay. That is
Okay.
minus 95 dBm given, right?
So sensitivity
Range,
power.
D is also given, right?
So you said sensitivity is power.
Yeah, receiver, since this power received is the minimum power that we can receive. Okay, minimum power that we can receive. So minimum thing is that is the sensitivity. Okay, minimum power that we can receive is known as sensitivity. This frequency, this formula is derived from here. We receive, we if we will make it PR min, that will become sensitivity. Okay, it will become sensitivity of receiver. Are you getting me?
Yeah.
Okay, these are given. Okay, now you tell me in freeze equation we have PT, GT, GR, right? 4 pi dy lambda square, right?
Yeah.
Right?
Yeah.
And we have to find PT, right? But apart from PT, we also don't know the lambda, right?
Yeah.
So how we can find the lambda?
Lambda is C over F.
Right? Lambda is C over F. Okay. So but C, it is of the range, right? So
Yeah.
which frequency I will take? C varies from 888 megahertz to 960 megahertz. So for finding PT, what we can take?
Maybe we should calculate for the bottom.
So yeah, this is one typical question. So I will write PT here. We have to find PT equal to PR into 4 pi d by lambda square GT into ZF. Okay. Now I will put lambda equal to C by F. Okay. Then it will be 4 pi d C into F. Okay. GT GR. Okay. Now I will write.
It's
Yeah.
900. It's 950 to 1.3
What? Answer.
frequency.
Frequency is 880 to 960 megahertz. Right?
No, 950 megahertz.
One minute, 1 minute, 1 minute. Let me check. Okay, yeah, sorry. F is 950 megahertz to 1.03 gigahertz. Okay.
Yeah.
So they are asking what is transmitted power needed. So can you understand it? What, suppose I am just asking you that that your parents is asking you how much money you needed. Okay. So what does it mean? It must be mean that how much minimum money that you needed, right? So if PT is how much PT is needed, transmit power is needed, is mean that the minimum transmission power is how much? Are you getting it?
Yeah.
So for minimum transmission power, you can see PT is directly proportional to frequency. So what I will put? I will put the F equal to 950 megahertz, right or wrong? Are you getting the concept or not?
So we just pick the minimum frequency.
Yeah, we can put the minimum and we can find these values. PT equal to PR 4 pi D C square. This F square I am putting it out. ZT, ZR, everything you have to bring into the, you have to convert into the normal form. Into, we can't put here dB, okay? So you have to just like 10 log GT equal to 15, okay? 1.5 dB. Similarly, 10 log GR equal to 12, okay? And how you will convert dBm to the normal form? What? How you will convert? Do you know how to
No.
convert it? You know?
Oh, with log.
dBm is there. For converting dBm, you have to do this one. Okay. You have other one are in dB. It is in dBm. So you have to multiply by 10 raised to -3. Are you getting the concept? Are you getting it or not?
Yeah.
Why I did and what is our requirement? All those things. Okay.
Yeah.
Got it?
Yeah.
Okay. Okay. Very good.
So we just don't need that 1.03 information at all.
Which, no, yeah, that they have given. Suppose if you can satisfy this power at this frequency, you can automatically satisfy at this frequency, right?
Okay.
Correct or not? If you get the minimum power that you are required, then you can have it at this one also.
Okay.
Got the concept or not?
Yeah.
And do you have radar in your syllabus?
What?
Radar in your syllabus?
I don't understand.
Radar is in your syllabus. I'm seeing question from radar.
Okay.
Is it in your syllabus?
In my what?
In your curriculum, do you need to study these things? Because I am seeing in your previous paper questions from this topic.
I don't know. I sent the module outline and everything.
Yeah,
so-
but there this one is not mentioned. That's why I'm asking you.
I guess then.
Yeah, because in one of the paper they have asked question from this topic. So that's why I asked
Are
you.
you going by the slides?
Sorry?
Going by the lecture slides I sent.
Okay. Yeah, you have sent it the lecture slide also. Let me check in that one.
I mean, this is just what we've done so far, but it's I'm just saying, are you going by the lecture slides?
Yeah, I'm that is the first lecture slide, right?
Um,
Okay. Okay, we will see. We have time, we will see. Okay, that was just phrase equation. I've just taken one question from your. Okay, I will go from lecture slide point by point. Okay, it will be good if you'll also have the lecture slide with you. We can go it. Okay.
Yeah.
Right. We have seen why we required wireless system, right? And what are the advantages of wireless system, right?
Yeah.
Everything we have seen. We have seen different wireless band, right? From till what is the extreme low frequency band, high frequency band, medium frequency band. We all those saw it, right?
Yeah.
Now we will see the transmission, receiver, and these all concept, how these things happening. Okay. After that, we will see the transceiver and receiver designs. Okay.
Okay.
Okay. What do you mean by transmitter? Transmitter is things that transmit things. It means that it is responsible to send signals into the atmosphere. Okay. There is a device that sends signals its surrounding atmosphere, right? It is transmitting, just like sun is transmitting the energy, sun is transmitting the light. It is just like, think if we have a transmitter that transmits the signals. Okay, transmitter transmits the signal. So what they transmits? Transmitter transmits the information is being fed to it, and they transmit the information. Okay, they transmit the information from one place to another. Okay, for transmitting, this is our transmission system. for transmitting any signal to the surrounding, the transmitter equipment require a device that is known as antenna. Agree?
Yeah.
Agree or not? This
Yeah.
require a device that is known as antenna. Okay. What do you mean by antenna? Antenna is a transducer. Antenna is a transducer which converts one form of energy into other. Okay. So basically what they are doing, they are transmitting the electrical signal from this equipment. Electrical signal are being transmitted to the antenna, and these antenna are converting those electrical signal into EM wave, Okay. It is converting those electrical signal into the EM wave, and this EM wave is transmitted as a information. Are you getting the concept or not?
Yeah.
Okay. So we have transmitter. In our transmitter block, we have transmitter and we have one antenna. That antenna converts our signal to the electromagnetic wave. Okay. It launches the signal as an electromagnetic wave. Okay. And signal arrives at the antenna via a cable. Okay. Via a cable. This is a cable. Okay. This is a cable that is known, or this is a cable that is a waveguide. Okay. That is waveguide or transmission line. Okay. Or transmission line. Okay. So we have a transmitter, and between in our transmitter section we have a transmitter module, and between transmitter module and antenna we have a cable that transmits that helps into the carrying the signal from transmitter to antenna, and antenna launch the signal launch signal into space as EM wave. Okay. Okay. So if somebody is asking you what does transmitter include, so you can say that transmitter includes a transmission section and an antenna block, and both are connected via a cable. Okay. Understood how does the transmission of a signal happens? Okay. Or do you have any doubt?
No.
Okay. Let's see another. We have the transmitter. Now we will see the receiver concept. Receiver. Okay. In the receiver, what will happen? Just opposite thing will happen. In the transmitter, what was happening? Signal are being transmitted from transmission signal to the antenna. After that they are launching into the space as an EM signal. Okay. But at the receiver side, signal will first come to the antenna. EM signal will first come to the antenna, and this antenna will again connected through a section known as receiver section via a cable that is a waveguide or transmission line. Okay. These EM signal again got converted back into the electrical signal with the help of the antenna. Okay. With the help of the antenna. So receiver antenna, what they do? They collect the electromagnetic wave in its vicinity. See, we have the many electromagnetic wave. Okay. What do you mean by in its vicinity? It means that whatever the waves that are coming to it, they are collecting that. Okay. So this is receiver antenna, and receiver signal, input signal collected by antenna. It amplify the signals and send it to the users. Okay. So again, suppose someone is asking you what is receiver, you can say that receiver is a block, is a module in which we have a transmission section and receiving section. receiving sections. Okay, and what does in the receiver happen? In the receiver in the receiver, first the antenna section will take up the EM signal and convert back into the electrical signal and send it into the receiver part. Okay, and from there it can be taken by the receiver and they can analyze the signal. Okay.
Yeah.
Okay, now we will see both transmitter and receiver in the two-way communication, how it is happening. Okay, so you can see we have a transmitter. Okay, and we have receiver. Okay, we have receiver and we have antenna here. Okay, we have antenna here. So what will happen? The information will go from here. Okay, and first what will be the path? Information will go from here to the transmitter, and it will taken up by the antenna, that is the transmitting antenna, and it will launch as a EM signal into the atmosphere. Okay, but at the receiver part, this signal will be taken up by the antenna, and this EM wave are sent to the receiver signal, and here we can fetch back the information. Are you understanding how does its function?
Yeah.
Okay, it is a two-way communication in which we are simultaneously, suppose I am talking to you, you are talking to me, we are just following this two-way of communication in which it means that simultaneously information is being transmitted, antenna are transmitting into the space as an EM signal, and simultaneously EM signal is converting it back to electrical signal, and receiver is fetching the information. You are saying something to me, I am getting it. It is as simple as that. Okay.
Yeah.
It is a two-way communication in which we have and this antenna, if antenna and if transmitter and receiver section using same antenna has using a one common antenna, that antenna known as duplexer. Okay, this antenna known as duplexer, it means that it is serving the purpose of both transmission and receiving section job. Because of duplexer, we are not required to have both two antenna, one for transmitter and one for receiver. Duplexer is serving as an antenna for both transmission and receiver section. Are you getting my concept or not?
Yeah.
Okay.
Yeah.
Okay, so transmission receiver can be combined using serially though, and this section is we can call as trans receiver because we are trans. Okay, this is our trans receiver. Okay, this is trans receiver. Are you getting the concept or not?
Yeah.
Okay.
Okay.
Now we will see. Now we will see the. Uh, we will see how that receiver is being designed and how the transmitter are being designed. Okay. Okay, for that we need the knowledge of radio link design. One topic in your syllabus is given radio link design. Okay. We will go to this topic now. Radio link design. What do you mean by radio?
Radio,
Do you
as
have
in
any?
like device,
Yeah, tell me.
like the device radio link, or
No,
just radio
radio.
wave.
No, radio is a radio wave or radio. Radio means a signal. Radio means a means of communication between two individual or two devices that are physically apart from each other.
Yeah.
Okay. And They are named as a radio because they are using radio waves.
Yeah.
Okay, are you getting me? That they are named as a radio because they are transmitting on a frequency, or they are transmitting the signal, electromagnetic signal, and those electromagnetic signal are termed as a radio. So that's why if somebody, if two devices, two-person, individual, or is communicating with each other, or communicating or broadcasting, or if if I want to broadcast something, that can be accessible, or that can be accessible to everyone, I can use the radio signal to transmit my data. And it can be reached to those person which are very far from us. So that is the radio. Okay, so basically here we will study how we are designing the radio link. What do you mean by link? If I want to transmit my information, if I want to transmit my information to some other places, I want to link with them. Okay, so for linking with them, we are required to have some design. How we are designing our radio link, that is this topic name. Okay, are you getting what is this radio link design topic means?
Yeah.
Okay, so I will draw the diagram. Concentrate here. This is transmitter, okay, and this is receiver. Okay. In transmitter also we can have one antenna. Here we can have one antenna. Okay. Here we will have the signals. Okay. Signals. Okay. And that signal is known as EM signal. Okay. Electromagnetic signal. Okay. Okay.
Yeah.
Now you tell me, I am sending a signal. Okay. That signal I am indicating by S. Okay. That is signal. Okay. But the thing is that we are transmitting in our environment that are prone to noise. So we must consider N also, noise also. Right or wrong?
Can you repeat?
We are transmitting some signal that I am denoting by S, transmission signal power. Okay. But
Yeah.
in our environment, these transmission signal will be prone to noise or not.
Okay. Yeah, we will.
It will be prone to noise. So our concern should be only to the signal power, or we should also focus on noise power also, right?
Yeah.
Because if our signal power is S and noise power is N, if we are if this, suppose unfortunately noise power got increased, our signal will got deteriorated or not.
Yes, it will.
So what will define our transmitter figure of merit, or how can you tell that whether my transmitter is good or bad? Which parameter will determine? Will the S/N ratio will determine it or not?
Yes.
So ideally, what should be your S/N ratio?
It should.
Very high, as much as high possible, right? Right or wrong?
Yes.
If our noise is getting increased, this overall parameter will get decreased. Yes or not?
Yes.
It means that our signal to noise ratio is getting deteriorated. Suppose in your television, when you are watching television, or when you are talking to someone on your phone and you get budge sound, or something irritating sound of the network issues, what do you mean by that? It means that your noise is getting very high, so that you are not able to what is the actual signal. You are not getting the information, right? Right or wrong?
Yes, right.
Okay, so this is our signal to noise at the input. Okay, this is also known as signal to noise ratio. You might be heard SNR. What is it? What is the SNR of your device? It should be high, right?
Mhm.
Okay. Now tell me, how much power I want at receiver and how much power I transmit at receiver. That is our requirement, that whatever the power that I am transmitting at the transmission section and the power that we are receiving at the transmission signal should be more or less same. If we get the same signal, it means that our job is done, right?
Mhm.
Suppose I'm transmitting 10 watt of signal and I am getting a 99 point of watt of at the receiver, then almost our job is done. We are not getting any type of noises, much noises. But here in our radio link design, we will see that this environment is susceptible to the noise. Okay. So
Mhm.
that link we are designing. Okay.
Mhm.
Okay. So basically, we have a transmission section, we have antennas, and noise can be contributed to by anyone. This waveguide can also contribute noise. This antenna can also contribute noise. This environment is contributing the noises. These can also contribute noise. This every device can contribute the noise. Okay, every
Mhm.
device can contribute the new noise. Okay, so we will see the antenna. Okay, how the transmission happen in our in the radio design. We will see the antenna concept. After that, we will see the how this propagation is happening. Then we will see the link budget. Okay, then we will working on RF world. Okay, then our communication satellite examples. Okay,
Mhm.
okay, we will see. See, here our we are sending input power pi, and we have antenna, transmission antenna, and it is transmitting the signal as a EM wave launched. Okay, this is our input power. It is guided by a waveguide. Okay, so what does this antenna is doing? Can you tell me what does this antenna is doing? First of all, do you know what is waveguide? What is guided medium? What is unguided medium? Do you know what is guided medium? What is unguided medium? Do you know?
Um, Not exactly.
Okay. See, guided medium is medium that we can say that waveguide is a guided medium. Okay. It means that it is a medium that are bounded by a boundary and signals are being transmitted in those medium. It means
Okay.
that we have a boundary. Okay. And signals are
Like,
being transmitted in this
like,
fashion. Okay.
is that like a physical boundary?
Not a physical boundary. We can't have the physical boundary, but suppose that you have a cable. Okay. You have a cable. Okay.
Okay.
You have a cable, then that cable has a boundary or not,
Yeah.
right?
Yeah, that's what I meant. Yeah.
Okay.
Yeah.
Are you getting the concept or not?
Yes, I'm getting. I'm getting. You can speed up.
Okay, I can speed up. Okay. And what does the unguided medium means?
So there's no boundaries. It's more.
So can we say that air is unguided medium?
Yeah.
Okay. So can I tell that antenna is sending my signal from guided medium to unguided medium?
Yeah.
Can we say?
Yeah.
So we can have another definition of antenna, that antenna is a device that are translating signal from guided medium to unguided medium.
Yeah.
Okay. Okay.
Yeah.
So we are giving input to the antenna and these are being sent it to the unguided medium. Okay. Now the term efficiency will come. These type of questions are coming in your examination. And what is efficiency of antenna? To calculate the efficiency. So how you can define the efficiency of antenna?
Efficiency. Like how
How
much
well it is launching the EM signal, right? Suppose I am giving P input here, I'm getting PT here. So our efficiency will be PT by PI, right?
Yeah.
And generally practical antenna has efficiency less than 1. What do you mean by less than 1? It means that some of the power is getting lost, right?
Yeah.
Some of the power is getting lost due to the antenna, effect, due to the antenna as a antenna losses. So here we will have the antenna losses. These words I am telling you, just uh, remember this type of word and get familiar with this type of word, because in your question paper you will get efficiency, antenna losses, these type of words very frequently. Okay, very frequently. Okay. So what I did, I have given a signal from one signal or information are being transmitted via waveguide to antenna, and antenna launched those signal into the air, okay, as an EM wave or into the space. Okay, and here we are getting some losses as an antenna loss, right? I have shown you one losses here. Okay, and that's why some of the power is getting lost. So now at the receiver we will not expect the same power that being fed as an information. The power I will get at the receiver will be of the some less watt. Okay, but it is not end of a story. We will have more losses onwards. Okay. Okay, so first losses I told you, antenna losses, and how does it happen? I explained you. Okay, so another parameter, one parameter of antenna is antenna loss efficiency, one parameter efficiency. Okay, one parameter is antenna loss. I described everything. You will get every formulas for this also. Antenna losses, efficiency formula of antenna is R radiation by R radiation plus RL. Okay, R radiation means radiation resistance of antenna, and RL is loss resistance of antenna. Okay. Okay, so this is the efficiency formula of antenna, of any antenna. Okay, and RL is the loss resistance, that is the antenna loss. So we can see that as the losses are increased, our efficiency are getting decreased or not. Right or wrong? As losses are increasing, our efficiency is decreased or not?
It's decreased.
Decreased, right? And one more thing, this R radiation signifies that how much power we are radiating it. Okay, it means that it is a good parameter that being designed. If radiation resistance of antenna is high, it means that the antenna is very good efficient. Okay, because it will give more efficiency. Are you getting my point?
Yeah.
Okay. Now,
Yeah.
another parameter of antenna, we studied efficiency, we studied antenna losses. We will study the another parameter of antenna as a radiation pattern. Okay, radiation pattern. What do you mean by radiation pattern? Any idea?
Like in what way the waves are going or something.
Yeah, see, radiation pattern of antenna is the graphical representation of radiation properties of the antenna as a function of space. Okay, as a function of space. It is graphical representation of the radiation properties of the antenna as a function of space. Okay. Okay.
Yeah.
Understood?
Yeah.
Okay. See, if we are sending a signal to some place, okay, at receiver side, we are interested in the input power, right? At the transmitter side, what we are transmitting, okay? But at the receiver side, we will be interested in how much power we are receiving. Are you getting my concept or not?
Yeah.
Because suppose this is our antenna, okay, and after this we are transmitting PT at a distance of d. We have another antenna of receiver, and it is taking a p, and he wants to know that how much power we are getting at this antenna. So how can we represent that? Suppose you are transmitting 10 watt of signal here, and you are interested at how much watt or how much power you will get here. So for that, you have to know that power density. Okay, power density that will be defined by PT by 4 pi d square. Are you getting the concept or not?
Yeah.
PT 4 by d square. This is power density and its unit. Also, always remember unit also, because sometime in your question they might give you data but not the name. But with the help of unit, you can understand which data it is. If it
And
is watt per meter, yeah, tell me.
what's the symbol for power density?
Watt per meter square.
No, symbol.
Symbol
Not.
means PD. It depends. Somewhere you can see that they are denoting by S. Somewhere you will see that they are denoting by WR. So
Okay.
it's depend. But you can understand it. If
Yeah.
they would have given you that PT is 100 watt, and distance between two antennas is 10 meter, you can easily find the power density, right?
Yeah.
Okay.
Yeah.
Understood what is power density?
Yes.
Okay. Okay. Uh, okay. This radiation pattern of antenna determines also how the power density varies with angle or direction. You can think that if two antenna are placing it directly in LOS, LOS means that LOS is a very good term you will see very frequently. LOS means that line of sight. If two antenna are being placed at line of sight, the power density will be maximum. Okay, but suppose if we need to transfer, if our receiver antenna is at this place, so again it will be our power density will get decrease. Okay, our power density will get decrease. Why can you tell me?
Because the angle is changed.
Because of angle has been changed. Can you tell me what is this one? This distance then will become, it won't become d cos theta.
Oh yeah.
Yes. And can you tell me if theta is rising, what will affect on cos theta?
So
It will decrease, right?
yeah.
If theta is increasing, cos theta will decrease. So what will happen to the PD, power density? Now our PD will be 4 pi d. Now I will put d cos theta, iska d dash, I can make it. Our d dash will decrease, right? If theta increasing, d dash will get decrease, right? So
Yeah.
this is the, in that case the power can increase also. Okay,
Yeah.
in that case power can increase also, but sometime what happens that because of these angles the power decreases also. Are you getting me? Are you getting the concept or not?
Yes.
Okay, using the using numerical you will understand it much better way, but first let's cover it, these type of theories, okay, so that you can have a more visualization. Okay, so what our radiation pattern says that how power density varies with angle or direction. So radiation pattern will tell you what will be the power density at different angle and at different direction. Okay, so that you can place your antenna in that angle and in that direction and you can receive the maximum power. Are you getting it? Whether this radiation pattern is useful for an antenna engineer or not. This radiation pattern is a quite useful parameter for an antenna engineer, because with the help of a radiation pattern, they used to have a simulation type of thing, a normal software from which they can get the radiation pattern, and from that radiation pattern they can analyze that at which place he or she should place the antenna so that maximum radiation can happen, so that he can receive the maximum power. Are you getting the concept or not? Okay. Okay.
Yeah.
And one of another important parameter of the antenna is directivity. What do you mean by directivity? Do you want, suppose this is your antenna and this is your antenna. Do you want that this antenna should transmit to this antenna only?
Yeah.
Yes or not? So this is the directivity property. It means that the direction in which the antenna is intended to send the signal, in that direction, whether it is sending the signal or not. If it's sending the signal in that direction only, it means that antenna is is a good directivity. You must be wondering that from we are sitting on the ground, on the ground, and the satellite are moving in and around. Okay, in and around, but our antenna, but in our phone there is a small antenna that helps us to tell us the GPS location, GPS, and the satellite of the GPS is placed around 20,000 kilometers away from us. Okay, and that satellite is also moving. for fetching the correct information, the antenna of our phone is aligned with the satellite. Okay, it means that the antenna that we are using here and also in the satellite are directional in nature. Are you getting the concept or not?
Yeah.
So directivity is a very important parameter of the antenna. Okay. So, so if somebody is telling you antenna is a directional antenna, it means that both antenna are being communicating with each other directly, and we can define the directivity formula of antenna. Directivity formula of antenna D is 4 pi u p radiation. 4 pi u into p radiation. And this directivity defined as ratio of radiation intensity in a given direction from the antenna to the radiation intensity averaged over all direction. Are you getting it? What does it mean or not? Are you getting it?
Yeah.
So basically, this is this radiation and intensity in a given direction from the antenna to the radiation intensity averaged over all directions. This P radiation is being averaged over all directions. That's why it is known as P radiation. And this U is intended towards a one direction only.
Mm-hmm.
Okay. Okay, understood. Any doubt till now?
No.
Because I told you many parameters today. Antenna losses, efficiency, because in your last two paper na, they have given most of the questions from your antenna.
Mm-hmm. Okay.
They have given most of the questions from your antenna. So you should be aware about this formula. These are very basic formulas. I will move to some of the good formulas also, some of the typical formulas also. But you have to first understand it, that how this directivity is meaning, what is the meaning of the directivity. Okay.
Mm-hmm.
In that way, you will be able to correlate with your bigger question, because if you go through your last 2 year question, they have given a very bigger statement, very bigger word. If you will not have the good concept, good clarity, you will get fed up and you will get confused, totally confused. Okay.
Mm-hmm. Okay.
Okay. So that's why I am repeating it every time. Okay.
Mm-hmm.
I told you directional antenna. Okay. Directional antenna means that one antenna is sending a signal to another antenna one antenna that is intended in some other direction, in the direction of the other antenna. That is directional antenna. Okay. Another antenna we used to tell is a reference antenna. Okay. Reference antenna, that is also known as reference antenna. That is also known as isotropic antenna. Isotropic antenna. Okay. It radiates in all direction. Isotropic antenna radiates in all direction with no losses. Okay. So can I conclude that power density will be also same at all angle? Power density will be same at all angles. Okay. And a practical antenna, we can't have a isotropic antenna as a practical antenna. What do you mean by isotropic? Suppose this is our antenna and it is radiating at uniform throughout everywhere, but practically it is not possible. Okay, practically it is not possible. Reference this isotropic antenna, practical it is not possible. Okay, it is uniform. Okay, it is uniform in one plane, uniform in plane. Okay, it is a hypothetical antenna. It is hypothetical antenna and it do not exist in practical. Okay. We use this reference antenna to compare it with real antenna. We wanted to become like a reference antenna. Okay, we compare our real antenna with our reference antenna, and we do in that way. Okay. Okay. Today we have studied a lot of good topic about radiation of antennas. In next class we will see antenna gain. Okay, and some numericals on antenna gain and all those things. Okay.
Okay. Yeah.
Okay, after that we will go to the receiver antenna. We will see the reciprocity theorem, and then we will move ahead. Okay.
Thank you very much.
Okay.
No,
Yeah.
I will go to the material obviously again. So if I have any question, I will ask on the next class.
Yeah, sure. Go to the material. You also go to the material. I am also going through your material only because I am seeing there are typical questions there. So it will be very good for us. Okay.
Okay. Thank you.
Okay. Okay. Thank you. See you in the next class. Bye.